most latest research reveals an international vaccine candidate that offers superior long-lasting COVID-19 immunity, potentially minimizing booster requirements. Novel findings from a preclinical head-to-head comparison show that administering a COVID-19 vaccine as a nasal spray rather than subcutaneous injection enhances the body's long-term immune memory, thereby increasing the vaccine's overall effectiveness. This research could help pave the way for a COVID-19 vaccination strategy that depends on fewer boosters to achieve the same level of protection against SARS-CoV-2 viruses. A team of scientists led by Duke Nose Medical School had discovered a potential international vaccine candidate that provides improved, longer-lasting immunity against SARS-CoV-2 viruses compared to when giving as an injection. By triggering an immune response directly at the point of entry, the intransdermal vaccine candidate enhanced long-term immune memory of the virus, which could translate to a reduced need for a booster source. There is a growing evidence that intransdermal vaccines provide greater protection of mucosal surfaces, making this a vaccination route that could reduce breakthrough infections and subsequent transmission of the virus. To delve into this, the research team, which includes collaborators from Duke Nose parents universities, Duke University and the National University of Singapore, among others, compared the immune responses from nasal and subcutaneous administration of the vaccine, as well as immunity from the vaccine with and without the use of adjuvant substances added the vaccines to enhance the body's immune response. Published in eBiomedicine, the findings showed nasal administration of the vaccine candidate boosted mucosal antibody response as expected. Additionally, and more importantly, it enhanced longer-lasting mucosal and systemic immune production through preferential induction of airway resident T cells and central memory T cells. They told our data show that compared to subcutaneous vaccination, the intransdermal route improved the response of certain immune cells known as T cells, which reduced disease severity, explains Associate Professor Ashley St. John from Duke and NAS Emerging Infectious Disease Program, who is the lead author of the study. Not only that, but it also resulted in a greater number of T cell memory cells compared to subcutaneous vaccination, which could lead to longer lasting protection. T central memory cells plays a vital role in safeguarding the body upon re-exposure to a virus. They enhance the immune system's memory, inducing long-lasting protective immune responses. This ability to retain this long-term memory of the viruses suggests less need for a pathogen challenge to achieve the same level of protection against the virus, potentially translating into fewer boosters.